Hi all, so today we are looking at another system design or let's say low level design problem, which is ATM, design ATM. So this is a frequently asked question, and again, as you know, as already mentioned in previous videos, that I'll more than the solution, we will focus on the thought process on how to achieve the solution, what all is expected in an interview. And yeah, let's get started. So I have noted down few focus points. Basically, these are the points we will be focusing on when going through our solution. First one is obviously requirements gathering, which is the foremost and most important point for any LLD problem. We need to be very sure of the functional requirements which we will be implementing, and here we have to do a good deal of communication with our interviewer. Second step is identifying the entities, because once we have written down the functional requirements, it's easy to figure out the entities. Third one is figuring out what design patterns we could use. So here I have listed down a list of frequently used design patterns. For ATM design, we have to focus on state design pattern and chain of responsibility design pattern. Both of these are let's say the prerequisites for this problem. Then we will focus on class relationships and diagrams. This is one of the most important points of a LLD interview. Then API design. Now this depend on the interviewer. If they are interested in the API design, they would ask you to work on the API design. So we will take a look at the API design for ATM. And yes, so whenever we are writing the code, or let's say not writing the code, but when we are working on this class relationships and diagrams, we need to take care that we are enforcing the OOPS concepts: encapsulation, abstraction, inheritance, polymorphism, because chances are at the end your interviewer might tell you to point out if your code is following all the OOPS concepts. Similarly, our code and our class relationships, basically our design, should enforce solid principles. So we should be able to tell that yes, our code or our design is following the solid principles. Other than that, we will also look at the database schema. Again, we will not focus too much on it, but yeah, we can go through it once. And yes, I'll also show you the code which I have written. Okay, so we have also coded the solution. Obviously I'll not go through the code line by line, but definitely I'll give you an overview of my code. And okay, these are few good resources which I found for any LLD problem, so I will add them to my to the video description. Okay, so let's get started. Requirements gathering. So yeah, so whenever we talk of an ATM design system, so before we actually start with the requirements gathering, if you could just pause the video and try to figure out few requirements on your own. Okay, and that would actually be the requirements which we have written here, because there is no rocket science involved. For ATM design, we know that at an ATM we can withdraw cash, we can view whatever our current account statement is, we can deposit the cash, and initially when we insert the card, we also enter the pin, right? That is how we are authenticated. Otherwise we will not be allowed to perform any operations. Here, since we are focusing on the ATM, we will not focus on the bank or the bank's service too much. But yes, the ATM service will interact with the bank's backend to authenticate and validate transactions. ATM itself will not perform any authentication or debit or credit of money on a user's account. And these are few concurrency requirements. We can maintain transaction history, and it will have a cash inventory, because ATMs have some certain specific denominations and certain number of notes of those denominations, and that is how it is able to give us cash. So let's move on to the next step, which is identifying the core entities and the relationships. So okay, before we dive into this, we also need to be sure of what design patterns we are using, because based on the design patterns we use, you know the class diagrams change a bit. Okay. Anyways, our core models will stay the same, so we can go through our core models, which are user. Obviously, a user is an actor, or a user is the actor which will use an ATM system. Then we have a card, which is basically the ATM card. Here we are calling it a card. Okay. Account, which is the user's account. Transaction, which will hold the details of debit or credit. And ATM. These are the core entities. These are the models. So models can somewhere be mapped to your database tables. Okay, so think of it like we have database tables which are taking care of these models. Okay, and so to store different denominations of cash like 2000, 2500 and all that, we are using an enum node. We are using another enum transaction type which will have cash withdrawal, cash deposit, transaction status, ATM status. Okay. Now okay, we don't have to go into these. Okay, let's go through our code. Let's go through our design patterns first, and then we'll come back to these. Okay. So yeah, so what design patterns we are using here? So as I previously mentioned, state pattern and chain of responsibility pattern are very important for an ATM design question. So we will be using the state pattern to manage ATM states. Now what do we mean by ATM states? So essentially, let's say when you come, suppose you have entered ATM location. So initially the ATM is idle. Okay, and then what you do is you insert your card. Okay, so it goes to a card inserted state. So these are the different states in which your ATM machine is. Okay, card inserted. Then what we do is we enter our pin, and then the pin is verified. So let's say the machine goes into a pin verified state. Okay, after verifying the pin, we can select any operation, basically what we want to perform, withdrawal or deposit or any of that. And after that, the machine goes to a processing state, and after that we can eject our card and the machine will go back to the idle state. So these are the states I have identified for my ATM system. You can add more states or reduce the states as per your convenience. Another design pattern is chain of responsibility pattern. So for chain of responsibility pattern is basically used for dispensing the cash. So basically here what happens is that, let's say we are saying we have 2000 denomination notes, 500 denomination notes, 200 denomination notes and 100 denomination notes. Okay, so essentially what happens is, let's say a user says that they want to withdraw 10,000. Okay, so what we would try to do is, so for an ATM system, we want that we should be able to get that amount to the user by selecting the maximum denomination. So if someone is asking for 10,000, I would want to use all the notes of 2000. Okay, and if it's not sufficient, then we will move on to the next. If 500 is not sufficient, we'll move on to the next. So this here this is very similar to the chain of responsibility pattern, because in chain of responsibility pattern we have multiple handlers, right? And the object passes through all of them. So here our object, or let's say whatever the amount requested by the user is, will pass through all of them and we will decide if we are able to dispense the cash. So this is the logic we will be using to dispense the cash. Okay, so yeah, these are the two patterns, the state pattern and the COR pattern. Let me just remove all of this. Okay, now let's do one thing. Okay, I think we can go through our design. So let me just zoom into this again. I think okay, this is fine. Yeah, okay, I can zoom in more. Okay, so if you remember, initially we designed certain models. Okay, so these are our model classes. Okay. Yes, so user. So here we are not very much concerned about user. Okay, see, our main system is of ATM, so user is there as an entity, but we will not interact much with the user. So user has an ID, it has accounts. Accounts is a list because a user can have multiple accounts, also a user can have multiple cards. Okay, let's focus on the card model. Okay, so card has a number, a username, expiry, pin, and a card is associated with an account. What do we have in account? An account number and current balance. So see, we are trying to have as minimum attributes as possible, because the more we complicate our system, the tougher it is to implement in an interview. Okay, so we have card, we have account, we have user. Then we have transaction. Transaction is just an entity which will tell us, what, whether someone has withdrawn the cash or deposited cash. So transaction has ID, transaction type can be cash withdrawal or cash deposit. Then we have amount. Okay, transaction will have an amount, a transaction will have a status. So we have implemented different status here, but for the sake of simplicity, we will not be looking much into failed transactions or in progress or stuff like that. We will assume that whatever transactions we are doing, they are successful. Okay, a transaction is linked to an account. Obviously, a card is linked to an account. So essentially, whatever is happening, the debit and credit, that will happen on the account. But who will do it? BankService. So here we have delegated the task of debit and credit to the BankService. So here, our system will essentially contact the bank's backend and perform these operations. So in the BankService, if you see, it is performing all the operations for us: validating card, validating PIN, checking the balance, debit and credit, and we are taking the necessary inputs. Now let's focus on the state design pattern. So as we mentioned earlier, that for ATM state we will be using the state design pattern. So the basic boilerplate for state design pattern is you have an interface which has all the methods, and then each of your individual states implement all the patterns, and the methods which it cannot implement, we will return an exception for them. Okay, so here we have an ATM state, we have insert card. So let's see, so here we are going sequentially. We will first insert the card, then we will enter the pin, then we will select the operation. Based on what operation we have selected, we will withdraw the cash, we will deposit the cash, we will check the balance, or we will eject the card. And as soon as we check the card, we can again start from the first state, right? So we have 4 states. Idle state. From the idle state, when we perform the insert card, we move to the card inserted state. On the card inserted state, we perform the enter pin and we move to the pin verified state. On the pin verified state, we perform the select operation and we move to the processing state, where in the processing state we have 4 functions available: withdraw cash, deposit cash, check balance, or eject card. Now if you want, you can have another state for card eject or something like that. That is totally dependent on your implementation. Okay, so this is the state design pattern, and okay, we will talk about the ATM service at the end. Okay, other than that, okay, this is one of the core models which we talked about earlier. ATM has an ID, location, which are not very important, but an ATM has a node count, which basically maintains how many nodes it has of a particular denomination. Okay, this is very important for the cash dispenser. And here we are using the update inventory method to update the node count. Okay, and this is the enumeration I have used for nodes. Now let's talk about the chain of responsibility pattern. So for chain of responsibility pattern, you have an abstract class and one or more number of concrete handlers. So these are the handlers, and the object will like pass through each of these handlers. So here we have 2000 dispenser, 500 dispenser, 200 dispenser, 100 dispenser. Inside cash dispenser, we have a next dispenser. So essentially, so let's say we will start with 2000 dispenser. From 2000 we will move on to the 500 dispenser. From 500 we will move on to the 200, and from 200 we will move on to the 100. Okay, and all of these classes will implement the dispense abstract method, where we will try to dispense a particular amount, and we will keep on updating the nodes count. Okay, we have to ensure that our nodes count is updated in the ATM class. Okay, now to manage all of these classes, we have ATM service. So an ATM service has ATM current card. So basically I'm using a singleton pattern to implement the ATM service. Okay, that is why I have a static instance for the ATM service. Current state, which basically means the current ATM state, a cash dispenser chain, and the bank service. So all of these are we require them throughout our ATM service. So ATM service has these following methods which you can go through. Okay, so we are done with the class diagram. We can also go through the UML. I don't think it is required. Yeah, I think that is more than enough. We have gone through the class diagram. This is just the UML for it. Okay, so we can go through the solid principles now. Okay, let's go through the solid principles now. So basically we want to ensure that, so basically in any interview, the interviewer would want to understand how you are following the, or how are you adhering to the solid principles. That is why I have added this small section over here as a revision. Okay, so let's go through all the design principles one by one. First is single responsibility principle. So if you can see in our class diagram, every class has only one reason to change. User card account, they handle only user account card related data. Transaction represents only transaction details. ATM maintains inventory of nodes. So this is the benefit of having smaller classes. Okay, you are concerned with very little, so you can implement it very easily. Bank service handles only validations and account operations. ATM service, which this I can understand is a big class because it orchestrates all the operations. Okay, and a cash dispenser chain classes. Okay, we are also following the OCP, which is open closed principle, because if you look at our cash dispenser, if we have a 50 rupees note, which we have, like if I try to add 50 rupee note to my ATM machine, I just have to add a 50 dispenser. That's it. I will not have to do any modifications to the existing dispensers. Then in the state pattern as well, as I mentioned, if you want to implement more states, you can also implement maintenance state or any states for your at your convenience. We are also following the LSP. Derived classes are replaceable by their base classes, which means instead of basically like wherever we are using idle state, we can use the ATM state. Okay, interface segregation principle. So we should not have bloated interfaces. Okay, so we should, now here the state design pattern somewhere messes up the ISP, because you see that idle state, or let's say PinVerified state, basically all of the states are implementing all of the methods, not the ones which they will actually support, but all of the methods. Okay, that is why but again if you want, you can choose to ignore this in an interview. Okay, and dependency inversion principle, of course we depend on abstractions and not concrete classes. So if you so just now we went through our class diagram. So ATM service is dependent on the ATM state and not any concrete ATM state. Okay, similarly cash dispenser and bank service as well. Okay, and we have also taken care of all the OOPS principles. So basically encapsulation is being followed. We are bundling data with behavior. Okay, account has account number and current balance, and it is not being modified directly, rather through the bank service. Similarly, we are also following abstraction. Abstraction comes by default with ATM, state design pattern or COR pattern. Okay, we are also following inheritance. We are using cash dispenser, and that is the parent. Then we have all the child classes, 2000 dispenser, 500 dispenser, and all that, and we are following the polymorphism. So basically the idea for this section is that we should be able to answer in an interview that how our code is following a particular principle. This is a very favorite question of interviewers, and that is why when I was working on this code, working on the this problem, I thought of noting all of this down. Okay, so we are done with the oops and the design principles. So now let's go through the database modeling, and then we will go back to this API design. So for database schema, I haven't found much resources online. This is something I found good, this Medium blog, so I'll again add it to the description. But yeah, like how to work on the database schema. Let's think which classes are persistent or which ones are transient. So the persistent ones like user, account, card, transaction, ATM, these are our models. They will become the tables, okay? And the transient ones like ATM service, cash, dispenser, they will remain in memory, so they will not go to DB, okay? Now we don't have to be very perfect with the database schema. We just have to maintain or come up with the basic or the most important tables which we require for a ATM design. Okay, so okay, so here let's say, so yeah, we have created certain tables. So users, we have created the users table. Users table will have a user ID. Do not pay attention to all of this. We have an accounts table. Okay, now let's see when we were drawing the class diagram, we said a user can have multiple accounts. Okay, one user, multiple accounts. So whenever we have a 1:n relationship, know that or at the side of n, basically for the table where we have multiple relationships, we need the foreign key of the one relationship guy. So here since a user can have multiple accounts, we need to have the user ID as a foreign key in the accounts table. Okay, so this point is noted down very well in the Medium blog which I did. So again, I'll add it to the description. So here for accounts, we have account ID and we have user ID. Okay, and other than that, account number and balance and all that stuff. Similarly for cards, a user can have multiple cards, right? So in the cards table, we need to have a foreign key of the user ID. So this is important. Okay, again, a transaction is linked to an account. A transaction can have an account, or let's say a transaction will have an account, right? So for a transaction, we have account ID as the foreign key. Okay, so this is about the database schema. We really don't have to go into much details. So now let's talk about the API design. So for the API design of ATM system, again, let's think of the system flow. Insert card, validate PIN, choose operation, withdraw, deposit, check balance, get the receipt, check the card. Okay, so let's go through one by one. Insert card. Obviously it will be a post request, because when you insert your card, you will give your card number. So now this will happen on which resource? On the ATM resource. We are calling the insert card method. Okay, and in the request body, so whenever we have a post request, we have to update or send a request body. And here we have card number, whatever it is, a integer, whatever, basically it could be a string as well, anything. So and in the response we will get a session ID, which will determine that we are authenticated or we are logged in. Okay, now validate pin. So again, on the ATM resource, we invoke the validate pin method. Now since we have received the session ID, we are passing it as header. Okay, and with the validate pin, we will send the pin, and in response we will get a authenticated true. So this is this is the sunny case. In the rainy scenario, we might return authenticated false. Okay, then we have withdraw cash. So on ATM, we go to the withdraw, we have an amount and an account ID, and in response we'll get a transaction ID and the status and the dispensed notes and the balance. This is same for deposit cash and for balance inquiry. For balance inquiry, we are running balance. So balance inquiry is a get method. Okay, so we are sending the account ID in the query parameters, and in the response we are getting the balance. For mini statement, if you want all the transactions done at the ATM, we can again look at the account ID. We can also pass the ATM ID depending on if we okay. So we are working on a resource, working on the ATM resource. So we will get all the account or all the transactions done by this account on this ATM. Okay, and print receipt. This is a post request. We'll send what transaction ID we want to print, and we'll get the printed receipt. Okay, so this is the design. Now again, before looking into any of this, you should ideally try to come up with the functional requirements, try to come up with the design with the UML diagram. Try it yourself first, only then this will make sense, because it's not tough to come up with these things. These are easier things. Yes, when we implement a particular design pattern, that's when we have to modify our design and adapt our design to that design pattern. Anyways, I mean, if you try it again and again, you should be able to figure this out on your own. Okay, so now I think we can move on to the code. Okay, so let's take a look at the code. So okay, so here first of all, let's go through what all folders we have. We have enums, we have models, we have servers, we have state. So models, let's go through models. In account, again account.java. So in account, we are only maintaining the account number and the current balance. We have getter setters and the constructor. So I'll not go through the getter setters and the constructor for any of the classes. Okay. Then we have a card. Again, for a card, we have number, username, pin, account. A card is linked to an account with expiry. All of this. Okay. Again, we have getter setter functions. Then we have a user. So a user has a list of accounts and a list of cards. Now whenever you have a list, you can implement the add function rather than the setter function. So basically, rather than set accounts, it makes sense to have add account, because you will add accounts one at a time. Okay. Similarly, we can have add card. So this is the user. Now let's go through atm.java. So inside an ATM, ATM has ID, the location, and the nodes count. Basically, what are denominations? So basically, we are trying to map that for 2000 denomination. How many nodes does it have? Okay, so that is the nodes count. Here we have a update inventory method. So whenever we withdraw cash, we have to update the inventory, right? So we this is the list of the this is a map of the nodes dispensed, and we are iterating through it and accordingly updating our nodes count on the ATM. Okay, I have made these synchronized so that if multiple threads are trying to access it at once, we will not mess up with the with this update. Okay. Yeah, I think we have done all. Okay, transaction is left. So again, a transaction has transaction type, which can be cash withdrawal or cash deposit, amount, transaction status, local date time, basically the timestamp of the state of the transaction, and the account to which the transaction is linked. Okay, and other than that, we have getter setter functions, nothing different. So this is the model. Let's go through the enums which we have defined, although we don't have much to understand over here. For nodes, we have 2500, 200, 100. For transaction status, pending in progress field success. For transaction type, cash withdrawal, cash deposit. Now let's go through the state, or let's go through the dispenser first. So cash dispenser.java, this is an interface. Sorry, this is an abstract class. Okay, this is an abstract class which has the next dispenser and a setter function for the next dispenser, because we will go sequentially from 2000 dispenser to 500 dispenser. Okay, so yeah, this is how it is, and this is the abstract method which all these four classes will implement, which is the dispense. So you have certain amount, add the node count, basically the initial node count, and this will return the dispensed node count. Okay. So I'll not go through all of these, we'll only go through one of these. So let's look at 2000 dispenser. So at 2000 dispenser, we have implemented the dispense function. So we have some amount and we have an initial node count. Okay, so we are trying to check how many 2000 rupee notes are available, and we are trying to check how many are required. So we will use the minimum of those. If it is greater than 0, we will update that okay, we have dispensed these number of 2000 rupee notes. Okay, and also the node count will be updated because we have used some. Okay, so we will subtract that count from here, and the amount will be updated because now we have we have managed some of the amounts. Okay, let's say if I was trying to withdraw 2100, then I have managed the 2000. Now only 100 is remaining, so that is why we are updating the amount. And if the amount is greater than 0, right, if we have some amount left, what we are trying to do is dispensed, and we have a next dispenser. Okay, so like from 2000 we can move on to the 500 dispenser, then we will go and perform the same operation in the next dispenser. Okay, so for 2500 we have this next dispenser dot dispense, and also for 200. But for 100 rupee, we will have at 100 we will say cannot dispense full amount available denominations, because here now we don't have any more denominations left. Okay, we cannot have a next dispenser for 100 dispenser. Okay, that is the lowest amount of denomination we are supporting. Now let's look at the state pattern. So again, this is an interface, ATM state. It has all the functions: insert card, enter pin, select operation, withdraw cash, deposit cash, check balance, eject card. These operations are simply a flow which happens when you use an ATM machine and nothing different. So as I said initially, the ATM machine is in idle state. So when we are in the idle state, we can only perform the insert card. So see, in the insert card, we have mentioned service dot set current card. Okay, because this card will now be used by the entire service, and current state new card inserted state. Why? We are done with the idle state. As soon as we have received the card, we can move on to the card inserted state. For all the other functions, we are throwing an unsupported operation exception. Okay. So we go to the card inserted state. Inside the card inserted state, we have implemented the enter pin. Okay, so we have not yet seen the bank service and the ATM service. We will go through it. So here we are utilizing those services. So bank service is validating the pin for us. As I previously told, all the operations will be handled by the backend of a bank service. Okay, we will not handle the bank. An ATM will not validate the pin, right? So bank service will validate the pin, and based on if the pin is valid, we set the state to pin verified state. We move on to the pin verified state. Okay, in the pin verified state, we implement the select operation where if user presses 1, they would be able to withdraw the cash, 2 to deposit, and 3 to check balance, 4 to check the card. So based on whatever user is selecting, we are setting an operation type on the service, and accordingly we will call those methods. Okay, then we have the processing state. In processing state, we have implemented all the withdraw cash and all that core methods. So let's go through them one by one. So withdraw cash, again we are calling the bank service. Bank service is debiting the amount. If the debit is successful, we are noting down the dispensed notes, updating the inventory, basically the number of notes in the ATM, and creating a transaction for it and returning the transaction. Similarly, the same operations are being performed for depositing the cash. Here we are calling the credit method, and then we have a check balance function. Again we are calling the bank service check balance function. And eject card, so as soon as we eject the card, we update the current card to null and the current state to idle state. Okay, so now let's go through the service files. So bank service has all the methods. Okay, validate card. So here I've just simply returned true because we essentially don't have much logic to put in here. Validate pin, so we'll check that the incoming pin corresponds to the pin as mentioned on the card. Okay, then we have check balance, so from account we are returning the balance. Now this is a synchronized method, so that if multiple threads try to access it at once, we they shouldn't be able to. Basically only one thread will enter the function at a time. Okay, debit, so again for debit what we are doing is we are getting the current balance, and if the current balance is less than amount we will not be able to withdraw the money. Otherwise we will update the balance in the account and we will also withdraw the amount. Similarly credit is also implemented. Now let's go through the ATM service, which is orchestrating the entire flow. So in here we have ATM, we have card, which is basically the current card inserted to the ATM, the ATM state, the bank service, the cash dispenser. Now here I'm using Singleton Pattern for the ATM service, that is why I'm using static instance, and an operation type. Okay, so when we instantiate the ATM service, again this is private because this is a singleton method. If you are not aware of singleton design pattern, you can read about it. That is a very 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 important design pattern, so you must be aware of that. So yeah, again when we instantiate the ATM service, current card is null because then we will perform the insert card and set the current card. Okay, then here we have the dispenser, we have updated for 2000, next dispenser is 500, for 500 it's 200, for 200 it's 100. Okay, and we start the chain at 2000. Okay, this is a public static method for get instance. Okay, these are some getter setter functions. Okay, now insert card, enter pin, all of these functions are here and they are calling the function on the state, the current state of the ATM. So whenever, so see, insert card is calling this current state insert card. Okay, so for all these functions we are calling the state ATM state classes. Okay, so now let's look at the main.java where we have a short demo. So we are creating a new bank service, we have created a user, we have created an account, and we are creating a card. So we are adding that account to the user and adding the card to the user. Our ATM state is idle. Okay, initially state will be idle. Nodes count, so see I am adding 10 nodes of 2000, 10 nodes of 500, 10 nodes of 200 and 10 nodes of 100 for an ATM, and we are creating an ATM here. Okay, and here we are creating a service. Okay, the ATM service. Okay, and now we are just simulating a flow where I am manually inserting the card, or I've simply called the function insert card1 and enter the pin. So here I'm passing the correct pin. Okay, and then we call the select operation. So we will keep on selecting the operation. Basically whatever the operation is selected by the user, withdraw or deposit, based on the operation type selected, we are performing certain operations. Again here I'm hard-coded amount. I'm not taking input from user, we can take input from user as well. Okay, we are calling the service.withdraw cash. See, we are not calling the state, we're not calling any functions on the state, we are only calling our service class, we are only working with our service class. Okay, withdraw the cash, and then as soon as withdraw is successful, we are setting the PinVerified state, because we can again select any other operation. This will continue. Okay, and once we eject, the system will move to the idle state. So yeah, let me run it once. Let me run it. So welcome to ATM, inserting card is inserted, enter PIN. So as I had hard coded 1234, so PIN is validated and moving to the next state. So let's deposit some amount. So that also I have hard coded. So let me just show you that here when we were creating the account, I set an original balance of 1 lakh rupees, and in the deposit I'm depositing to 20,000 rupees. So after depositing to 20,000, let's check the balance. The balance is 1,20,000. Okay, so which means I should be able to withdraw some cash. So now here when if we see withdraw, I have hard coded the amount 10,000. Okay, so if I try to withdraw, I'll be able to withdraw 10,000 rupee cash. Okay, and now again I can check the balance is 1,10,000. Okay, uh, yeah, and now I can eject the card. So card is ejected. Thank you. So yeah, this is a basic functional system. Now there might be bugs in the code, but the code is not the goal of a low level design round. The actual goal or the main focus is on the this part, the relationships part, the class diagram, the core entities, the API design, and all of that. The design patterns which we are using, if we are aware of the design principles, if our code is compliant with the OOPS patterns, and all of that. Okay. So yeah, I've tried to touch up on the more important parts for an ATM design. So yeah, that's it. I think that will be it for this video. Thank you.